Hello dear students. Today we will start the first chapter of standard 9, that is matter in our surrounding. This chapter deals with the basic chemistry. So let us start this chapter. So in this chapter the first word is matter. So what is a matter? So basically whatever you see in your daily life, whatever that exists in the universe, that can be considered as matter. Anything that exists in the universe can be considered as a matter. Now, everything in this universe is made up of matter, which scientists have named matter. So, everything in this universe is made up of material, which scientists have named matter. So, you know that in this universe, all the things that are made up of something, for example, water, we drink water every day. So, water is made up of hydrogen and oxygen. You know this one. Okay. So water is made up of hydrogen and oxygen, these two materials. So water is a matter. So anything that you see in this universe is a matter. Now what are the properties of matter? They have two properties, that they have mass and they have volume. That anything that exists in this universe has a particular mass and it occupies certain volume. Suppose if I give an example, if you take a brick, so the brick is having certain mass and it occupies certain volume. Suppose if you take a glass of water, a glass of water, the if you pour water inside the glass, it will occupy some volume within the glass itself and it will have certain mass. So anything that has mass and it occupies certain volume can be considered as matter. So basically whatever the thing it exists in the universe is a matter. So modern scientists have evolved two types of classification of matter based on their physical properties and chemical nature. So in modern era, scientists have classified the matter based upon their physical properties and chemical nature. Okay, what are physical property? Physical property that you can see. Okay, suppose what is physical property that you can measure. For example, mass, then its volume. These are physical properties. Okay, so in this chapter we are going to deal with the physical properties of matter. Okay, the physical properties of matter. In the coming chapters we will deal with chemical nature of matter. Okay, so next point is physical nature of matter. So matter is made up of particles. This is the first physical nature of matter, that it is made up of particles. Okay, particles. So matter to be continuous like a block of wood, or matter was made up of particles like sand. So earlier, some scientists, when it was not discovered that matter is made up of particles, some scientists used to believe that matter is made up of block of wood, some blocks, or it is made up of particles. Some scientists used to believe that matter is made up of blocks of wood, and some scientists believe that it is made up of particles like sand. Suppose this is a wall. Okay, this is a wall. So how a wall is made? With the help of bricks. With the help of bricks, cement and all that, wall is made. So some scientists used to believe that matter itself is made up of this type of bricks, that is block of wood, and some scientists used to believe that it is made up of small tiny particles. Okay, so we will see out of this one, these two, which one is true. Okay, so here we are going to conduct an experiment. This is a beaker. Inside the beaker water is present, water. Now here what happens, you take a tablespoon of sugar or salt and put it over here. Okay, and this is a beaker. You take some water over here, and you take some salt or sugar, then try to add the salt or sugar with the water, then stir it. Okay, then after certain time what you will see, the salt or sugar that you have taken is completely dissolved inside the water. You can do this experiment at your home. So when we dissolve salt in water, the particles of the salt get into spaces between particles of water. So here why the word particles is taken. So suppose if we consider that the matter is made up of blocks, these big blocks, it is not going to be dissolved inside the water. Okay, as because it is made up of particles, small tiny particles, it can be easily dissolved inside the water. Okay, now how the particles get dissolved inside the water? Suppose if you take one water molecule, suppose this is one water molecule which is made up of two hydrogen atom and one oxygen atom. This you already know. This is another water molecule. This is another water molecule. So this water which is present inside this beaker is made up of lots of millions and millions water molecules. Now how these water molecules are arranged? The water molecules, there is a small spaces between these water molecules. So among these water molecules, there are tiny places, small void or spaces. So when we add salt or sugar inside it, these particles of salt and sugar comes and they get deposited over here. Okay, these are small tiny particles of salt and sugar. So these get deposited, these gets deposited over here. Okay, so that is why the small particles of salt and sugar is occupying the space which is available within the particles of water itself, so it get dissolved. Okay, so this is how the particles get dissolved. So one thing you should keep in mind, this note, this is very important. The SI unit of mass is kg, this one everyone knows. The SI unit of volume is cubic meter. Okay, cubic meter, it is meter cube. The common unit of measuring volume is liter. Okay, so that these three points are very important. 1 liter is equal to 1 dmq. 1 liter is equal to 1000 ml. 1 ml, that is milliliter, equal to 1 centimeter cube. So this third relation is very important. When solving the problem, this relation is going to be used. Okay. Now we saw that the matter is made up of particles. Now we'll see how small these particles are. How small are these particles of matter? Okay, these are small, but how small? So here to conduct this experiment, what we will do, we take a beaker and we pour 100 ml of water. Then we will take 2 or 3 crystals of potassium permanganate. Potassium permanganate is a chemical. Okay, about this one we will study in the other chapters, and dissolve them in 100 ml of water. So we'll take a beaker, we take 100 ml of water, then we add 2-3 potassium permanganate crystal. So here what happens, the color of the water changes. So you can see here, this is little bit light blue color, although the water, it doesn't have any color. So to indicate this one, we have taken this little bit blue color, light blue color. So when we add 2-3 crystals of potassium permanganate, it color changes. Okay. Here this big dark pink color. So from here, this 100 ml of water, what we will do, we take 10 ml of water. So this is 100 ml of water. If we take 10 ml of water, 10 ml, here 90 ml remains. 90 ml. So that 90 plus 10 is equal to this 100. So out of this 100 ml, we have taken 10 ml. Then what we are going to do, add this 10 ml of water with 90 ml of fresh water. Okay, so let me explain you again. This beaker, it contains 90 ml of water. We are taking 10 ml of water, which where potassium permanganate crystals are being added. So from here we will take 10 ml of water, and this 10 ml of water we will add to this container that contains 90 ml of water. So 90 plus 10 becomes 100 ml of water. Okay, now you can see the difference between these two. The color of over here is little bit darker than color over here. Same process will continue for the next two times. We take 10 ml of water from here. Then this beaker contains 90 ml of water. We add these two so that 90 plus 10 becomes 100. Again we take 10 ml of water from here and we add this 10 ml of water here, which contains 90 ml of water. So 10 plus 90 becomes 100. Now you can see between among these four, the color difference between the color. Okay, different among the colors. So here the shade is darker, little bit lighter, again little bit lighter. This is the lightest among all. Okay, so estimating how small are the particles of the matter with every dilution, though the color becomes light, it is still visible. So here the as the liquid gets diluted, what is dilution? Dilution means addition of certain things into water. That is, if you add uh, if you add some liquid into water, that is called dilution. Okay. For example, you take some droplets of Dettol and you add those droplets of Dettol into water. So the Dettol or the water gets diluted. Okay. Concentrated means pure. Dilution means some particles are added into water. Okay. So here you can see that here the number, why this color changes, because here the number of crystals which are present in the water, or not the number of particles which are present in the water, decreases. Okay. So with this experiment, what we have concluded that the particles of matter are very small. It is very tiny. Otherwise, it would not have got transferred from this place to this place. Okay. The next point is characteristics of particles of matter. What are the characteristics? So particles of matter have space between them. So we have in the first slide we try to understand this one. So let us try to understand. In activities, we saw that particles of sugar, salt, or potassium permanganate got evenly distributed in water. So what is the meaning of this word evenly distributed? Means these, when you add a pinch of salt, sugar, or some crystals of potassium permanganate, throughout the water it gets dissolved. That is called evenly distributed. Similarly, when we take tea, coffee, or lemonade, that is nimbu pani, particles of one type of matter get into the space between particles of other. This shows that there is enough space between particles of matter. That means, suppose in a beaker you take some water. So these are the water crystals of sorry, these are the particles of water. Okay, particles of water. Now, within the particles of water, some particles of sugar, salt, or potassium permanganate. So, sugar, salt, or potassium permanganate comes and they get dissolved over here. So, they get dissolved over here. So, these are some of the crystals. Okay. This shows that there is enough space between particles of matter. Okay. Now, next point is particles of matter are continuously moving. So, earlier we saw that suppose if you take a beaker, you take some water and you add some crystals over here. That is, it may be sugar, salt, or potassium permanganate. It get dissolved. Now we'll see that when we add some crystals or some one liquid into another liquid or some crystals into a liquid, they do not stay there. They always revolve from here to there. So to conduct this experiment, what we will do, again we take a beaker, fill the beaker with water. Okay, water. Then what you will do, you in your bathroom, you must have ujala. Okay, that we clean our that is used to shine our clothes, white clothes generally. You add some droplets of ujala over here and watch it. What happens? So after certain times, you will see that the entire water it converts itself into bluish color. Okay, bluish in color. So you are adding ujala over here, some color over here. Okay, here in this region. But why the entire water is getting converted into a colorful water? Because from here the particles are moving into different directions. So particles of matter are continuously moving. From here you saw, that is, whenever we know that whenever something is moving, they possesses kinetic energy. So they possess what we call the kinetic energy. As now this point is very very important. If you rise this temperature, suppose if you heat it, if you provide heat over here, if you heat it, so as the temperature rises, particles move faster. So we can say that with increase in temperature, the kinetic energy of the particles also increase. Now suppose you are doing this experiment at 30 degree centigrade, you will do the same experiment at 35 degree. So whenever you are doing this experiment in 30 degree, suppose it is taking 5 minutes to convert the entire water into bluish color. When you do the same experiment in 35 degree, okay, then the entire water will be converted in within 2 or 3 minutes. So when we increase the temperature, the motion of the particles increases. Okay. So next point, particles of matter intermix on their own with each other. So when we add different particles, they get intermixed with each other. Okay, they do so by getting into space between the particles. So how do they get intermixed? How do they mix with each other? So the different matters having different insides. So how the matters are arranged, the matters are not continuously arranged, there is a void or spaces between the matters. So the smaller size of particles get the space which is available between the bigger particles. Okay, so this intermixing particles of two different types of matter on their own is called diffusion. This word is very very important. You will also read about this diffusion in biology. In case of water, it is also known as osmosis. Okay, so the intermixing of two different types of matter on their own is called diffusion. So diffusion is nothing but intermixing of different particles within themselves. Okay, we also observe that on heating, diffusion becomes faster. So here, when we increase the temperature, the rate of diffusion, that is the rate of mixture of one matter or one types of particle into another particles increases. Okay, so the best example of diffusion, whenever you are using, uh, so all of you might have been using deo and perfume at your home. So you are using perfume in this place in your room. Okay, but suppose your father or mother is coming through this door, they can also smell. They can also easily smell the perfume. How? Because the particles of the perfume started moving in all the directions. Getting they started moving in all the direction. That is called diffusion. That means the particles are mixing with the particles of air. Suppose in your kitchen, your mother is cooking your favorite food. Okay, suppose this is your kitchen. This room is your kitchen. This is your dining room. Okay, this is your dining hall. You are hungry and sitting here. Whenever your mother is cooking here, you can easily smell the food. You can easily smell it. So how? Because this is only because of the diffusion. Okay. Next point is particles of matter attract each other. So particles of matter have force acting between them. This force keeps the particle together. The strength of this force of attraction varies from one matter to other. So here, suppose we take a piece of iron. Okay. Now, can you break the piece of iron with your hand, with the help of your hand? No, it is not possible. Why you are not being able to break this piece of iron? Because this this iron piece is made up of very small pieces of particles. Now those pieces of particles attract each other. They do not want to get separated from each other. Okay, so here you are not been able to break it. Okay, now again you take a piece of chalk. Okay, suppose this is a piece of chalk. So chalk is used to write things in the blackboard. Now you can easily break the chalk. Okay, so this is also a matter. this is also a matter. In this case you are able to easily break it, because in this case the force of attraction between, or force of attraction among the particle is not strong enough compared to piece of iron. Okay, here also the intermolecular forces of attraction is there. Okay, that is the force of attraction between atoms and molecules, but it is not strong enough compared to iron. So different matters having different amount of intermolecular forces of attraction. So intermolecular forces of attraction means the force of attraction that is available within the particles. This is a binding force. Okay, so this is all about this class. So now there are certain questions. Which of the following are matter? You need to identify this one. Okay, so which are the matter? Just name it. Second, give reason for the following observation. The smell of hot sizzling food reaches you several meters away, but to get the smell from cold food you have to go close. So suppose your mother is cooking something at kitchen, you can easily smell it. But if the same food is already cooked and it is kept inside the freeze, then to get the smell you need to go nearby to that food. What is the reason? So as we know that if you increase the temperature, the diffusion increases. That is the reason. So when your mother is cooking, the temperature is more, so diffusion increases. When it is kept inside freeze, the temperature is low, so diffusion is also low. A driver is able to cut through a water in a swimming pool. Which property of matter does the observation? And so this question you try to think on your own and try to answer this question. But if you cannot, comment me, I will answer it. What are the characteristics of particles of matter? This one we have already discussed in this video. Okay, watch the video again and try to answer the question. Okay, so this is all about this video. If you have any doubt, then you can ask me. Thank you and have a nice day.